to Van Horn Metz Supplier Highlight Series. We're starting off 2022 with a new format for you guys. Instead of a short video segment, we're inviting our suppliers to join us and teach us a little more about their product portfolio. We'll spend some time today, about 30 minutes, with a company representative identifying markets and solutions for a variety of industries. So who should be joining us? I would say if you're working on the bench as a formulator, chemist, or lab manager, or if you're in procurement and supply chain, or purchasing working as a purchasing agent, or maybe as a manager in a sales region. This series is meant to help you solve your problems, and whether it's performance, supply, or price, these videos will help provide a solution. And to kick things off, I'm excited to begin this new initiative with Kuncai Americas, pearlescent effect pigments. We're joined today by Rick Kistler, their North American sales manager. He has spent a majority of his career managing visual effect pigments and has an extensive background and experiences spanning 30 plus years in the industry. Thank you for being here today, Rick. I will turn it over to you.
Great to be here, AJ, and I welcome the opportunity to introduce everyone to Kuncai Americas and Kuncai overall and all that we provide our various industries. So what I want to do is try to run through quickly what our basic products are and how Kuncai differentiates ourselves from the rest of the market. So what you're looking at here is actually our world headquarters. That is actually our plant number 2, where we do all of our coating and packaging. It's where our applications labs are located in Fuxing, China. To begin with, as AJ had said, we manufacture effect pigments. Effect pigments have previously been known as pearlescent pigments, which had been based almost solely on natural mica. And natural mica is still a very prevalent part of our product line. But where Kuncai begins to separate ourselves is we also manufacture our own synthetic mica, which, as you can see there visually, is much cleaner, obviously fewer impurities than natural mica. So that gives us a number of chroma and brilliance advantages when we get to the final product. But this is sort of the first step in how we put together our products. Our products are based on either natural mica, synthetic mica, or calcium sodium borosilicate, otherwise known as glass flake. So what we do is we take one of these 3 substrates and we mill it down to our particular particle size. Generally, we're measuring ours in microns. We consider something that's a very fine particle size to be classified as less than 15 microns. We have glass flake products, which are generally used primarily for sparkle type applications, and some of those particle size distributions go as high as 800 to 1,000 microns. So our products are typically the largest component of a plastic or an ink or a paint, but within our range, we can develop various types of effects based solely on the particle size. That's a very important variable for us. Here you're looking at a microscopic picture, again, of those 3 substrates. On the left, you can see natural mica. Across the surface of that and around the edges, you can see how irregular not only the edges are, but also that surface. In theory, we're trying to get down to 1 sheet of mica. But in reality, when the mica delaminates, you can see there are some residual steps, ridges across that surface. Once we start to deposit coatings, whether they're titanium dioxide or iron oxide or a combination of both, those very slight differences in elevation or steps across the surface can cause very small differences in that coating thickness. So as you look at that middle picture, the synthetic mica, you see much more uniform or rounded edges and a much, much cleaner surface that gives us higher chroma when that coating is applied to that flake. Gives us higher chroma, as I said, more brilliance. It's a better product overall. And then on the right side, you can see glass flake, which, as I said, is typically used for larger particle size sparkle type applications.
Rick, when you talk about chroma or vibrancy or sparkle, what determines or what dictates those characteristics?
So that's a perfect timed question. Once we take that particular substrate and get it to its particular particle size distribution, we begin depositing a metal oxide. The most basic product to start with would be a layer of titanium dioxide. And here we're showing that as we allow that TiO2 coating to build up on those flakes, we can stop it at particular endpoints to create different wavelengths, or we're basically changing the way light is reflecting and transmitting through these platelets. So if we put a very, very thin coating down there, as you can see on the left, the far left there, we are going to reflect essentially a white pigment or a silver white pigment. If we allow that TiO2 coating to build up to somewhere between 60 and 80 nanometers, we're going to start reflecting a gold or a yellow. We continue on to build it up thicker. We get red, blue, and green, just essentially working through different endpoints on the color spectrum. So we're just changing the way light is reflected. So as I said, with that coating thickness more uniformly applied to the smoother surface of synthetic mica, you get a much higher reflected blue, for instance. So the blue that reflects off of the surface of a synthetic flake of mica versus the blue that reflects off the surface of a natural mica interference blue, you'll see the difference. And I have some examples of that later on, but that higher chroma is definitely something that is an advantage to a synthetic mica-based product. So here, again, the way we create our products or the color or the effects is simply by letting a metal oxide like titanium dioxide or iron oxide by itself, which will create anything from a bronze to a copper to a red. Or if, as this little picture shows here, if we apply a coating of TiO2 and then iron oxide, we can create various shades of gold. So it's really nothing more than an encapsulated flake that's encapsulated with a metal oxide, which is how we create various types of color effects. Here's an example of a number of our interference colors. You're looking at an interference gold. I would call that an interference lilac or a violet, and then an interference blue. And all of those seed shapes, the left-hand example in each case is something that is done with synthetic mica. There you can see that they're higher chroma compared to the natural mica. So there's less haze, there's more brilliance, and I know that pictures do not always give the best representation, but I think if you are looking at the side-by-side examples, here's a way where synthetic mica clearly gives a better product. And there's a couple of ways to think about using that advantage. For instance, with the interference blue there at the bottom, you might be able to formulate with slightly less of a synthetic mica product. Or you could basically say, listen, you've been using that interference blue for years and years. If your customer is looking to improve that blue to create a more intense blue, you could look at using the synthetic mica product. So there's a couple of different ways to potentially look at the advantages of synthetic mica, where it could be used as maybe a cost savings because you're going to use far less to get the same color, or as an upgraded effect across any of our types of effects. The whites are cleaner, the reds are richer and deeper. Here, these interference colors are definitely more intense.
Rick, for looking at these two, or back a slide here, looking at the two differences between those materials, what is the transparency like? Because it almost looks like the opacity's changed a little bit on like the regular interference pigments. Does the opacity change as you change between different substrates?
There will be differences in opacity as well. So the biggest difference when it comes to particle size being the determining factor on opacity, a very slight change in opacity will, if you're moving larger in particle size, you'll get more brilliance and you'll lose a little bit of opacity. Because the synthetic products tend to be a bit more brilliant, they might be slightly less opaque, or in this case, they might appear less, I'd say, hazy, because that finer particle size natural mica, because of some of the impurities in a natural mica, you're going to see a tiny bit more opacity with the natural mica products as compared to the synthetic mica products. That's a good question.
And then,
very rarely are effect pigments looked at as a means of developing opacity. Typically, aluminum is used. TiO2 can be used in whether it's a paint or a plastic. Our products, okay, yes, they can either generate some opacity where our finer particle size products are creating more of a satin type of a luster. But generally, they're not the determining factor of opacity in whatever medium they might be incorporated into. They're all relatively transparent, even our finest particle size products.
okay. And then my other question for you, if you wanted to get a green, I know you have a green in your portfolio, but if you mix a yellow and a blue, say someone's buying a blue and a yellow, they want green. Mm-hmm. Do you get that effect with interference pigments if you mix, or do they cancel out, or what happens?
They will. That's a great question. That's a great formulation tip there. Actually, no, if you go back to this slide, once you start combining these interference effects, you're basically running light backwards through a prism. You're going to end up, in theory, with white light. You're going to go back to something that does not, as you said, take a yellow and a blue and expect to get a green. They will sort of cancel each other out, so you'd end up with something that's lost its color flop advantage. So that's why we have quite a variety of interference type colors. So if it is in fact a green that you're looking for, we do have an interference green. We've got some that are almost a very, very red shade blue or purple. We've got lilacs, red, gold. You can find your interference type color just by changing product. Plus, as I said, because they are transparent, most times you're going to use our products in conjunction with other transparent organic pigments, phthalo blue, phthalo green, any of the yellows, anything that's transparent, so that you can develop the color to hit a peach or a soft green effect, something like that. So in general, for instance, if somebody is looking to develop the color for a plastic shampoo bottle, they can either use a silver white product to get a soft peach, or another way might be to interpret that with an interference red that'll give you a bit of a red interference cast on that curved bottle. So there's a couple of different ways that you can sort of hit that same color space. But again, combining our products to get to a color in the middle is really not the way to go about it. If I jump back ahead here to where we see our products typically used, we have, I would say, three basic types of products. There are the industrial products, which are used in anything from seed coatings to plastics to printing inks and wallpapers. We have an exterior grade of products that are used in automotive coatings and coil coatings, those sorts of exterior durable application areas. And then we have a third area which have been treated for skin contact applications, which would be our cosmetics line. And really, all of our products are used across all three of those basic product areas. But when you get into the specifics of our market areas, certainly plastics or the master batch industry, color concentrates is one of our largest application areas. We see applications in deco arts and craft paints, powder coatings, really anywhere that color is used, concrete flooring coatings, things like that. The way these products can be stirred into almost any medium, and that's another key point to make, is that there's really no milling or grinding that's required for these dry powder pigments. Typically, they're used at a relatively low loading, somewhere between 3 and 5% in a paint or a plastic at most. incorporated with as low a shear as possible, because you don't want to be fracturing those platelets, which will simply start diffracting light. So they're easily incorporated. They will settle, but it's not like a metallic pigment, which will have a very definite hard settle at the bottom of say a craft paint. They can simply be redispersed relatively easily. They are acid alkali resistant. Most of them are FDA approved for food contact packaging, those sorts of things. So it's a very safe and inert type of product that's used pretty much anywhere that color is used these days.
I have a couple questions for you here. So
yep.
You talked about shear and incorporating into a liquid medium. For like plastics, if you're extruding them, how much shear, like twin screw, what kind of shear?
Yeah, I would say that at this point in the history of the use of our products, the plastic color concentrate companies are well versed in the use of what screw design is best for these types of products. I know that they're used in single screw applications. They've been used in twin screw applications as well. They've actually, I'd say over the years, increased in usage now that most shampoo bottles or packaging plastic bottles are multi-wall, so that they've got that inner regrind material, and only the very outer skin of these bottles is actual new color, which significantly decreases the amount of, say, full color usage through the wall of a shampoo bottle, which means that they can use higher end products because they're going to use, say, at least 1/3 less of that new resin in that outer wall of a shampoo bottle. So there's obviously, within the color concentrate extrusion process, there is some shear. And again, I think that one of the longer term advantages of synthetic mica is that when you are using, say, some of the larger particle size types to get a bit extra brilliance, synthetic mica has been shown, and I don't have any data on this, but it's just been shown to be a bit more flexible. So I think you see less fracture that would come from any inherent shear in a process, whereas with a larger particle size natural mica, you might see a bit of haze develop when the chips are actually molded, and that's simply just the nature of natural mica and that process. But one of the things that we're looking to do is sort of study maybe how much better synthetic mica is in those types of processes, so that less is fractured means less haze, means cleaner color, more brilliance, all the advantages that you would want from a product like that. So it's an area that we're continuing to look for ways to promote the additional benefits of synthetic mica, in that it's a bit more durable. It can withstand maybe a bit more shear than its natural mica cousin. We also feel that long term, the overall sustainability story that accompanies the production of synthetic mica versus the mining of natural mica is another advantage for us, in that the carbon footprint is going to be smaller and longer term. I think there are obviously parts of our customers that are seeking that sort of sustainability partner more than just a pigment supplier who can supply low cost pigment. I think we've got some advantages for the big picture when it comes to who our customers are and what they can promote to their end customer, and ultimately the end consumer as something that's a sustainable product. That's an important point these days.
How many people manufacture the synthetic mica?
So synthetic mica is produced in a number of different industries, but we are the only manufacturer that is making a synthetic mica substrate for the pigment industry. Synthetic mica is used in electronics and things like that, but our particular grade, which is super clean, and the advantages are all visual, we're the only manufacturer. We're backward integrated that way, so that's another key point for us. We're also backward integrated into the production of the intermediates, where we're producing our own titanium tetrachloride and our own iron chloride. which during the precipitation process become titanium dioxide and iron oxide. So Kuncai is fully backward integrated into our raw materials, which is a big plus for us as well. So if I begin to sort of get to the specifics again of our product line, I would say that our first generation across the top there, the industrial grade there in the middle, I know it might be a little tough to read, but that's our Crystal series. That's our first generation synthetic mica. And then the Diamond series is our first generation glass flake there. Across the bottom, those are our second generation products. And really within the second generation products, if you recall when I talked about developing color by allowing the TiO2 to build up to certain thicknesses, Kuncai's labs determined that if we applied multiple layers, so if we stopped it at one endpoint and then put another separate layer on top of that, we could increase the intensity even further to create even higher chroma effects. So these second generation products using this multi-layering coating technology have increased the ability for us to generate really nice, clean, high, brilliant types of color across all three different substrate areas. And then lastly, these are sort of our exterior grades. So the exterior series encompasses natural mica and synthetic mica. There's really not a lot of glass flake used, primarily because the OEM paint manufacturers sort of have a set upper limit of about 45 microns, so they really don't need the glass flake types of products, unless it's for something like custom car paint, and that's a different story. But generally, our two most predominant second generation products for this exterior market would be our Cetalic range and the Zillamaya range. They exhibit significantly increased brilliance and really nice deep color across the entire spectrum of those types of effects. So that, in a nutshell, is who Kuncai is. We feel we are the third largest effect pigment manufacturer in the world, and as I said, we're really the only one when we talk about our competition that is doing strictly effect pigments. We're not making any organic pigments. We're not making any aluminum pigments or any other additives, things like that. We are strictly focused on high value, high performance effect pigments for our customers.
You have the exterior grade slide here. What makes a mica exterior grade versus non or industrial or interior?
Sure. So there is another surface treatment applied to those finished flakes, which provides additional humidity resistance. It's really not providing a significant amount of light fastness. Our products really don't have the need for additional light fastness because, again, there's really no extra chromophore in there. It's simply a white pigment that's at a particular thickness, changing the way light is reflecting and transmitting. So that exterior coating is more to prevent the wicking action should you get a platelet sticking up through the base coat into the clear coat of a car paint, for instance. That coating prevents that humidity from penetrating the coating, delaminates the paint, ruins the car paint. So it's really more for the protection of the humidity resistance in those sorts of applications.
As far as supply goes, where you guys keep most of these materials here in the U.S.? I mean, you're the North American sales manager. These are coming from China.
Yep.
Lead times and what's everything look like?
So our U.S. sales office is located in Columbus, Ohio. Our warehouse is just south of that in Grove City, Ohio. And yes, we are manufacturing all of our products at our plant, all three plants in Fuxing, China. So typically we are warehousing many of our most commonly used products in Ohio. But should there be, the need for one that we are not maintaining inventory on, lead time right now is typically about 12 weeks. Some of the higher end products we can bring in by air, and there you're looking at 2 to 3 weeks, and we've sort of factored that into the price of those products. But again, because we are backward integrated, even if we have to air freight in something for a particular customer, we're still very price competitive based on our overall production situation. But we've dealt very nicely with the supply chain challenges of the past year and a half. I know that our supply chain people really got out in front of some of the container delays and shipping delays, and we've really had very, very few back order situations. We've asked that our customers provide us with as much forecasting, so it's sort of a two-way conversation. But I've been very happy with the way our supply chain system, our situation has unfolded, and I think that most of our customers would comment the same way, that we've been able to keep our material on their dock, and that's a pretty big feather in our cap these days.
Very nice. Well, I don't want to take up any of more of your time here today, Rick, but it was very helpful to learn about how you guys are changing the effect pigment scape with your natural and really your synthetic micas, and how you're able to alter it to reflect light differently. So for any of you out there that are interested for more information, please visit our website at www.vanhornmetz.com. And our contact information will follow this presentation as well. So thank you for your time today, and we will see you next time on our next Supplier Highlight series.
Thank you so much.